Well, hi there, boys and girls. Today we're going to talk about derivatives of inverse functions. This gets a little messy, so I've got a picture on the right over here you can look at if you don't really care geometrically about what I'm talking about. Here I've got two functions, f and f inverse. And two functions are inverses of each other if they are reflections across the line y equals x. Today we're going to talk about the slopes of these lines at these reflection points. Of course, if f goes through y comma x, then its inverse goes through x comma y. And what I want you to see here is that at these, what I'm going to call flippy-floppy points, the slopes at those points are reciprocals of each other. If you could believe this slope right here was like maybe 1/2, then the slope here is 2/1. So these slopes are reciprocals of each other. The slopes are reciprocals at flippy-floppy points. And I'll do this xy and yx. That's what I'm calling by flippy-floppy points. I'm going to give you a formula for a derivative. Let's say that f and f inverse, so let's say f inverse equals h. So we're going to say f and h are inverses of each other. If you want to find h prime at a certain x, then this is equal to 1 over f prime at h's y coordinate, and I'm going to call that h of x. And this is the formula that we're going to use to find the derivative of an inverse function. So let's just get after this. I've got f of x equals x cubed, and I have h be the inverse of x, and of f, and I want to find h prime at -8. Now here is method 1. Method 1 is you can actually go find the inverse function for f. Since you have y equals x cubed, you can switch x and y, and you can solve this for y equals, and the inverse function is the cube root of x, which is x to the 1/3. So there's your inverse function. That is equal to h, and so you can find h prime, which is 1/3 x to the -2/3 power, and then you can plug in -8. This is not the fastest way to do this, by the way. This is the brute force method, which is 1/3 times -8 to the -2/3 power, which is the same thing as 1/3 times 8 to the 2/3 power. And if you remember, this is power over root. The 2 is the power, the 3 is the root. The cube root of 8 is 2, 2 squared is 4, 4 times 3 is 12, so this is 1/12. That was messy, that was ugly, that's not the point of today's lesson. The point is you're supposed to be able to find the derivative's inverse, the inverse's derivative by simply using f. And so that's what we're going to do, is use that formula. So let's grab a hold of an eraser and let me show you the correct way to do this without doing all of that messy stuff. So here's what we're going to do. We are going to say that h prime of -8 is equal to 1 over f prime at h of -8. So that's what we have to figure out. Now if h of x travels through the point -8 comma something, then that means that f of x travels through the point something comma -8. So what I'm going to do is figure out this missing piece here. When does x cubed equal -8? Well, that only happens when x equals -2. So there is our magic point. So h prime at -8 is going to be 1 over f prime here. There's h of -8. This is h of -8. So h prime of -8 is going to equal 1 over f prime at -2. This is going to be much easier. Here's f of x. F prime of x is 3x squared. F prime at -2 is 3 times 4, which is 12. So this is 1/12. That's much easier. Let's do another example where you can't find the inverse, or I think it would be hard for you to find the inverse function by hand, and so you're almost forced to do this. We want to find h prime at 4 if x is greater than or equal to 0. So h prime at 4 is going to equal 1 over f prime at h of 4. So what I have to do, again, h of x travels through 4 comma something, which means that f travels through something comma 4. We need to find this missing length. In other words, when does x squared minus x minus 2 equal 4? And so if I bring the 4 to the other side, that means x squared minus x minus 6 has to equal 0. And that factors into x minus 3 times x plus 2. So there's actually two places where this equals 4. One place would be at x equals 3, and the other one is x equals negative 2. Now, since this says x has to be greater than 0, I've found the missing link. It's at 3. So h prime at 4 is going to equal 1 over f prime at 3. So we can come up here and find f prime. F prime of x is going to equal 2x minus 1. Plug in 3. F prime at 3 is going to be 5. So this is 1/5. So really the first step here is you set f equal to this number and then do 1 over f prime at that point. Let's look at it in tabular version. Here we have a and f are inverse functions. That's what this negative 1 means. It means they're inverse functions. We want to find a prime at 4. Well, a prime at 4 is going to be 1 over f prime at a of 4. Or in other words, when does f have a y value of 4? So we come down here to the table and we find out that f has a y value of 4 when x is 2. So this is going to be 1 over f prime at 2. And so you can come over here to 2. F prime at 2 is 3, and so that is 1/3. So you're going to practice this tomorrow in class, and that's when I'll see you.